This is number 7 on your 7-3 homework. It is find the volume of a rotated section a couple of different ways over a couple of different lines. It says use the disk or the shell method depending on what method or what axis you want to rotate around. And so the first two were pretty easy. For A, it says take your y equals 6 over x squared and revolve that over the x-axis. You're going to lock this guy in between that function of y equals 0 and then x equals 1 and x equals 3. And so here's my graph right here. And I'm talking about this region wedged right in between. The red, of course, being the x equals 1, x equals 3. That little golden rectangle guy is just my little delta that we're going to be talking about. And he's going to be a delta x. And I'm right on the x-axis, and so this works out perfectly to go ahead and use a disk method, right? Because I'm going to swing this guy right around, and I'll kind of get like a funnily looking guy when I'm done revolving him. So that is going to be pi times my radius squared. My radius is, that height is just that function, so that's a 6 over x squared. Square that. Easy enough. I get 36 pi now that I'm going to take out. Well, the pi was already out there. Bring the 36 out. This x to the 4th I'm going to bring up, so I got x to the negative 4. Integrate that, so I'm going to wind up with a 36 pi over a negative 3. Of course, x to the negative 3. 1 to 3. This lovely piece right here turns into a negative 12. Plug in the 3, I get 1 over 27. Minus the negative 12, and then when you plug in the 1, you wind up with just a 1. So you wind up with this negative 12 over 27 plus a 12 times pi. Once you crunch that lovely number in your calculator, you get this, 104 pi over 9. And so this one's not so bad. Definitely want to use disk method since you're talking about all these guys are in, have x's, I'm going around an x, so I got a delta x. Everybody matches. There's no gaps. Life is good. Use disk method. The second one says go around the y-axis, same exact parameters, but this time we're going to want to use shell method because if I don't want to deal with this gap region right over here, right, that we'll see in the next part, then I need to anchor this little golden rectangle on the x-axis. But I want to go around y. And when those guys don't match, when they're parallel instead of perpendicular, that's when you want to use shell. So that's 2 pi times the integral. And the integral is going to be the delta x, the width of that rectangle. So that's, it's normally an x or a y, but it can be other things, and we'll see that in C as well. Times the height of the rectangle, which in this case is, again, 6 over x squared. That was the whole point of using the shell method, so that we didn't have to manipulate any of those functions. So now I have 2 pi times x, or times 2 pi integral from 1 to 3, x times 6 over x squared. Of course, that's going to clean up to 6 over x, which we are going to like because we're going to be able to pull that 6 out and just say, oh, well, he is, of course, my ln. When I integrate him, and I get 2 pi times 6 ln of x, go from 1 to 3. Easy enough. Pull out the 6, you get a 12 pi. ln of 3 minus ln of 1. Of course, ln of 1 is a 0. All of that for 12 pi ln of 3. Not so bad. Then I got to the last part. And for the last part, when I first looked at it, I saw it as a shell method. But after you go through this a couple of times, or you attempt a shell method, you realize shell method is a huge nightmare, but I'll show you it in a second. This is use disk. All right, so if we're going to use a disk, and then we're going to anchor this guy to my x-axis, I have a washer situation. My first radius is this whole big piece. I'm going around the line, y equals 6, and so that guy's going to be a 6. But I'm going to have some overlap, so I kind of drew a little picture over here. Here's this region that I'm swinging around of the 6, right? So I swing him around, but obviously he's way too much. I just want this black region. So I need to take out this piece up here. And this red piece that needs to come out, so that I'm just left with this, is 6 minus what's under this function. So you're subtracting out this black region so that you're left with this red value. And so essentially what we're going to say is purple and then minus this red region right here. And that's what's going to leave me with the black region. And so my first piece is going to be a 6, right? That's my first radius. My second radius that I actually have to take out is this piece in here, which is 6 minus what's underneath this piece. So that will take out this red region and just leave this black region behind in there. So it's almost the opposite of what you think it would be. And that needs to be squared as well. We're talking about this method, so I only have a pi out front. 6 squared, that's not so bad. You get a 36. This gets a little bit messier. I get a 36. Of course, it's going to be distributed, so it's a minus. This is going to be negative 36 over x squared 2 times, so negative 72 over x squared. Send the negative through, he'll flip to a positive. This will be a positive 36 over x to the 4th. Send the negative through, he'll flip back to the negative. 36 minus 36, he goes. And so I'm just going to clean this up a little bit, pull up the x to the 2, so he becomes 72x to the negative 2 minus 36x to the negative 4. This is a little bit easier to integrate. So he's going to be over a negative 1 raised to the negative 1. He'll be over a negative 3, so this is going to flip now to a positive 12 to the negative 3 from 1 to 3. And so now we plug in the 3. I get negative 72 over 3 plus the 12 over now 3 squared, so that would be 27 minus, now you get this 72 over a 1, so negative 72 minus this 12 over also a 1, and when you clean all of this up, you get a 328 pi over 9. I don't really like using washer method. I tend to look at them upside down. And so when I first looked at this, I said, oh, why wouldn't I just use a shell method? Because that's what jumped out at me. This picture jumped out at me. I said, oh, well, I can just do this. I got this little washer method going on in here, but he's not so bad, right? Because he's just a rectangle. I can figure that out without any calculus. It's got a radius of 6. I swing it around. No big deal. It was a nightmare. The picture on the calculator doesn't really do it justice. What happens is, first, of course, you need to flip this guy. And so if it was 6 over x squared, this is going to become x being the square root of 6 over y. And that's not so bad, right? That's easy enough. I said, all right, well, I'm going now from, instead of 1 to 3, I'm going 0 to 6. That's easy enough. This is my height of my rectangle, so that height's going to be the square root of 6 over y. And I can minus this 1 out, and no big deal. The picture doesn't do it justice in that when you get to here, actually, you have to cap this guy off. And so that you have 2 integrals. You have a washer method here, and then you kind of have an add-on washer over here. And we saw something like this earlier on that homework, but it was much more noticeable. It looked something like that. Penny is biting me. She wants to play. Here it wasn't as noticeable. So the first time I did it, it was kind of thrown off a little bit. And I was like, oh, it got real close, but I didn't get quite close enough. The other thing that you have to remember, that when you have a washer with this shell method and you're revolving around what would be parallel to an x, is that it's not a delta y. If you leave it just a y, that assumes this way. You need we wanted to go this way. And so you have to move this rectangle down from here, not up from there. And so you kind of have to go backwards. And so that delta needed to be 6 minus y, not just a y. Or else you get it backwards, right? We want to go and get the bowl this time. If you leave it just y, you get the funnel again, going this way. and and it just doesn't work out. So, long story, not so short. First part of it is that top piece. So you have the function minus the 1, no big problem. But you're not going from 0 to y because that's our little rectangle in there that you can't really see. You're actually going from this part right here, which is going to be, well, if this is 6 over x squared and this is at a 3, then this y value would be 6/9. So that was a barrel of laughs. So I have to go from 6/9 to 6. As this guy goes down from here, not up, it's going to be at the value of 6 minus whatever the y value I go down at. And then minus the 1. Plus this little rectangular region that didn't really look like a rectangle on the calculator. When you go through it and it spits you out a picture on here, it's much more noticeable, but it's not so noticeable on the calculator. And he's going from 0 to 2/9, and that part's not so bad. Now that one, you know what that height's going to be. It's always going to be 2 because you're going from 1 to 3 in there. Okay, so as if that wasn't bad enough, this part here needs to be distributed, and you get 6 radical 6 over y minus 6, right? You can distribute all of that, and then over here, that's nice. I cleaned this up a little bit with this 6 radical 6, and I brought this radical up, and so I had y to the negative 1/2, and I had this guy I changed to y to the 1/2. And then when you integrate everybody, you get this. And even the integration isn't so bad. What's bad is you have to go from 6/9 to 6. This part over here is not so bad, right? Plug in the 6, you get all of this, which I forgot to finish on that line. Because then I was like, oh, forget it. I'm just going to go to the calculator. And I use my stow button, and I typed this in, and I stored 6/9 in for x, and I hit enter, and when you plug in 6/9, you get 58 over 3. Okay, so 2 pi times this minus 2 pi minus that plus 2 pi, and then you plug in the 0 and the 2/3. Of course, the 0 is going to 0 out, so you really just plug it in the 2/3 there. This all comes to a 32 over 3. This over here is going to be 68 over 9. Add these two fractions. I kind of factored out that 2 pi, right? I got a 164 over 9 times 2 pi, and there you go. Same thing. Just a lot more arithmetic. So, much easier this way, as long as you're okay with this piece over that way.